Thanks. So the title of the talk is Efficient Word Lists, Why You Don't Need 25 Gigs to Be a Pro. And basically, the talk is around word lists and how they can go from being something we may take for granted and use very quickly. We just download them and throw them at passwords we're trying to crack. How we can get them to be actually quite effective for what we want to do and what we want to accomplish. So, as per mentioned, my name is Dimitri. I'm a penetration tester and password cracker. Just to answer the question about the academic, I don't have an academic background. I'm on Team Hashcat, and I didn't hurt too many GPUs in the making of this talk, although depending who you speak to, there have been some that have been set on fire in the past. Right, so if I turn this on, it'll help. Right, starting with the cat. Didn't want to be left out. I thought we'd go for Mr. Serious Cat. He's very serious about his word lists. He's got some passwords to crack, so he's basically our cat for this talk. Right, so why this talk? The reason is because many of us, whether we're researchers, we're hackers, pen testers, students, or just the average Joe, we may have tried to crack passwords. Either we're trying to explore it, we're trying to get into it, maybe we do it as part of our work. Regardless of what we do, we get into a position where we're not sure how to effectively use our word list in order to crack passwords. Those of us who may crack passwords, you may be in a position where you've got a word list, you think it's going to be very good, you're going to get something out of it. You load everything up, you load your hashes up, you stand back, you press go, and that's what happens. Right. So it can be very frustrating because sometimes you spend quite a bit of time downloading word lists, depending on where you come from. Fetching a 25 gig word list off the internet may take some time, may even cost you if bandwidth is expensive in your part of the world. So you do all of that, and then you'll end up not recovering anything. It can be very frustrating from that point of view. So how do we go about fixing that? First thing we need to look at is where we need large word lists and where we need custom or small word lists. Right. So if we look at different scenarios, for example, I know the patterns or hashes I'm targeting and I want a high success rate. In that case, you're going to use a small or a customized word list. Right. If your target is Bob's hardware store, right, you know his users are probably using passwords to do something like that. If your target's a financial institution, right, the company name, company location, something about the demographics about the company or its history probably forms a good or large part of the passwords that have been chosen. The city where the company is based, etc., like that. So small and customized word lists would work better in that scenario. Second one's the same. I know about the passwords the users probably used. Coming back to Ashley Haddison, for example. As per mentioned, some passwords there. We probably had a good idea of what some people chose. Right. But there's still a place for large word lists, for just the generic, all-in-one, everything thrown into one place type of word list. And that is if we have no idea what the passwords could be. So we don't actually know what the source is. We don't know how to target it. We don't know anything about it. In that case, something like that could come in handy there to have a very large word list along with your custom one. Or you have very fast hashes to crack, for example, MD5, in which case, from a GPU perspective, you're not very interested in targeting, customizing this to be a target attack. It's fast, just throw everything at it, see if something comes back. So sourcing quality word lists, where do we go to get good word list data from, right? And how do we add this and work with it so that we get something that increases the efficiency of cracking for us? First place is the web. Now, when I say the web, I don't mean looking for other people's word lists on the web. I'm talking about targeting websites to help you build word lists. Right, back to my original example. If it's a financial institution or a bank, scrape everything off that bank's site. All the words, all the things, directors' names, whatever you can find, makes a good word list to start off with from there. Right? If it's a particular site in a particular country, particular language that you know is the target, well, aim for that. Aim for websites and get lists from those particular countries. Next place is leaks. Leaks are generally good for building word lists because obviously they're passwords that have been used. If it's a leak that's very current, that's come out now, you also have passwords that you know were used in the wild currently. And so you can add those to your word lists and build them up like that as well. So, right. Then we have Pastebin. The reason why I'm putting Pastebin separate to the web, although you could probably wrap it up under that, is that you get really good stuff on Pastebin. And there's some guys out there who've made really nice tools for keeping a watch on Pastebin, watching what's happening. Or if you want to write your own, go ahead and do that. Pastebin's a very good place. You'll be surprised what people put on Pastebin. It's incredible what they've put on there. Passwords, configuration files. Oh, I want to share my config file with a developer. So I won't email it, that's too unsafe. I'll put it on Pastebin along with my SQL details, how to log in to the DB. I've seen everything from that to people who've stored their home passwords, their own personal passwords on Pastebin, probably under the wrong assumption that somehow no one else is going to see it. I don't know if they think the link is unique to them or what the story is, but you do get that. So keeping an eye on Pastebin is a good place to get these from. Somewhere else too is books. So books are good places to get passwords from, right? Especially passphrases, for example, by taking certain sentences out of books. So find these books. There's tons of sources on the web where you can get them in electronic format. Dump them, create word lists from them, and use them. Check the effectiveness of them. Obviously, books are a more broader sense of a password word list source, but still, they do make a good one. Then the last one is honeypots. And honeypots, we had a talk around something something similar yesterday. So attackers will basically throw anything at a site to try and attack it, be it SSH honeypots, web-based application honeypots, etc. And sometimes there's good stuff to find in there. What's interesting research if you want to do in your own time, I have tried it too, is if you obtain a leak and you have access to honeypots, compare the two, because what you often find is when your leaks come out, sometimes even before they've been made public, you start seeing those passwords hitting honeypots. Right, because these guys obviously have connections, they're getting them, they're firing them off. So it's a good place to get access to these passwords. Now, I've circled this into one bin, one item if you want, as how to source passwords for your word list. The reason I've done this is because there's two places to do that from. And the second one, probably the most important one of them all, and one that we sometimes forget to do, right? Add your cracked passwords back into your word lists again, especially if you've run rules, mangling rules, and brute force. Okay, because sometimes we do that, we get excited, hey, I've cracked a whole bunch of passwords, life carries on, those files get put by the wayside or deleted when you actually may have very good password candidates that you've created or that you've cracked that you could put back into your word list again. So between those two, you can create very good word lists, both targeted ones and good broad ones to use for your attacks. Just on the point of honeypots, some of the HTTP web honeypots I run have come across some interesting password candidates I thought I would share. So these are passwords that attackers have tried against the web applications. Again, similar mistakes to what we saw as well, is that often they seem to be sending the user and the password in the same password field. And then they also try some very strange things. I'm not sure who would use that as their password, but I'm trying to understand how exactly, do they count as those, or do they just, it's very strange. But we had quite a few of those hitting us as well as other ones. So honeypots are a good place to get these passwords and to add them. Right, so now that we've got all our lists, all our word lists, we need to process them. Because again, our goal here is not just to have large lists, it's to have efficient ones, which we combine with rules, which are also often called the mangling of the different password, the different plain candidates to crack passwords. So rules will take a password or a word and do something to it, capitalize it, lowercase it, add a digit, remove a digit. Now, because those run on CPUs and GPUs, they're more efficient than trying to have a data file or a text file full of those words and trying to crack passwords from them. For example, if you look at the words here, there's 10 words on the screen, right? Now, already you've probably found a base word in all of this because the human mind's very good at that. It's very fast at doing that. That's all good and well. But what's interesting to note is there's 10 words here that could have been in a dictionary that I would have been using to crack passwords. When in fact using just the default mangling rules that you get in Hashcat and John, I could get all of these password candidates if I were to crack them from only one word. So my dictionary would actually only need to contain the word Mercedes to get all of these candidates using just default rules that come with these tools. You would even have to develop your own ones. So that's what helps in making your word list efficient. Why have 10 words in it? Why get your GPUs to idle trying to do 10 words when you can give them one word, hit them with a whole bunch of rules, and get them to try different iterations, different mangling until you get what you're wanting. Right, so the key here is make CPUs and GPUs work, not the hard disks. Right, if your hard disk is super busy when cracking passwords, well, you may want to look at what you're doing because it should be your GPUs and your CPUs that are being kept busy with the cracking. So remove what you don't need and make your word lists smaller. Okay? So special characters, we don't need that in word lists. Even the most basic of rules and mangling rules will try special characters on your passwords. Lead speak, there are many default rules to do lead speak, so why have that in your password lists? Leading and trailing numerics, right? Password 1234, password 2015. You only need the word password in your word list. Rules can handle everything else around it for most of the passwords you're trying to crack. Right, pre-appending of years, capitals, duplications, and then mangled words. Right, so remove these from word lists because rules can usually do it far more effectively than trying to have every possible combination of one that you can get. So, looking at the practical side of this now, how do we practically show the difference between an inefficient or just a very large word list versus a more efficient one? So, there's a tool I wrote called Urasort, and what it basically does is there to optimize word lists. Now, it's not the only tool available. Other guys have written other tools. You're welcome to try write your own ones in your preferred language. I mean, it's in Python, so you can pretty easily see what exactly it's doing. The goal of the tool, though, is to take big word lists and give us something that's effective, that's targeted, that's sharp when added with rules and mangling rules, so we increase our cracking efficiency. So just looking at some examples of what it can do. Some of the standard stuff. Max length will remove all words over a certain length. Max trim will trim all words over a certain length. We can trim the digits of the start and end of words because rules can do that, so we don't want that. We can trim special characters from beginning and end of words. We don't want that either. We can remove duplicate words, right? So words can become just words because even your basic rule sets with your tools will do that kind of attack. No sentence basically desentensifies words by taking away the spaces. So your sentence becomes one long word. Convert everything to lowercase. Right. Even your most basic rules, basically every single mangling rule you can get out there, at some point will try capitals, capitalizing everything, capitalizing certain characters. So there's absolutely no need to have this in your word list. Keep them all lowercase. Wordify basically takes sentences and makes them new words. Right, what's an example of that just now? No numbers removes any words that are only numbers. Numbers are generally quick to brute force for most hashes. So they can take up quite a bit of space and add fat to a word list that you don't really need. Min length removes everything below a certain length. Dtab removes tabs. Duplicate sense basically takes a percentage and ignores a word if any single character is over the threshold of that percentage. If I have a word of Z, 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 ABC, right? And I have a threshold of 50 or 60%. It'll look at Z and say, well, Z makes up the majority of that word. We don't want that word. Because there's many rules for duplicating first and subsequent letters in words. So why have that in the word list? Hash remove is there to basically remove hashes in word lists. Especially if you've downloaded large publicly available word lists, you often get hashes in them. Or even, for example, if you're going through what your honeypots have collected, there's often hashes in there. Hashes are not words. They were probably sent by accident, or someone thought that passing a hash would get authentication for them. You don't need that. So it will look for and remove MD5, all kinds, NTLM, SHA, Drupal, Joomla, OS6, MySQL, and so forth. Email sort and email split. Basically, email sort takes an email address in your word list. So bob@gmail.com, and it'll create two new words, bob and gmail.com, as your entries. Split, I added because many guys like to have customized word lists for usernames and domain names. So what that'll do is it'll let you, instead of adding them as two separate words, it'll automatically let you specify two file names and output the user to one and the domain to the other for you, or append them actually. And then dewebify is there to remove HTML tags and all sorts of HTML and other characters from dumped web pages and try to return words for you or word lists for you. You can combine that with no UTF-8 to get characters that don't form part of the UTF-8 character set, and we'll see an example of that just now. So if we go through it quite briefly, what does each thing do? Dupe remove, for example, if that was the input candidate, the output candidate would be that. Tomorrow will be rainy. If the input candidate was that with the wordify function, it would then return those separate words for you. There's an example I gave you with the dupe sense of 70%, so that word just would not be included in the output. Email sort with an email address would give you those two new words, or email split would put those into the particular files you specified. And then the dewebify command would take away the HTML and other markup and give you just your word behind you. So if we look at an example, right, so here's the Mercedes file that we had. Okay. Right, we've got quite a bit in there that we don't want, based on what I've just said. I'm sure you can identify certain things that we wouldn't want in our word list, because we can do that with rules. So first thing we're going to do is give it the input file. In this case, we'll give it the merc.txt that we created, and we're going to convert everything to lowercase. Right, so there's output in lowercase. Now you can chain the commands. I'm chaining them to demonstrate this. I don't recommend you just do that though, because if you don't get your sequences right, you may come out with wrong things. Like if you run a min length first and then start trimming characters, you're going to have characters below the minimum length that you actually wanted. So just be sure to order them correctly. So there we've removed the digits now. Special characters are going. So that one there, as you can see, has now lost special characters. And it's interesting to see how the base word is starting to appear now, when we're stripping everything we didn't need that we could do with rules in that file. And then we've also got that one that we want to fix as well, because we wouldn't want that in there. So I'm going to type that command. I changed the parameter for that, so you'll see I typed it wrong now because I changed the word. It's not dedupe, it's dupe remove. Right, so there it's removed. And now we have just our base word starting to appear on that list. So once you've done that, what's very important is to then sort, obviously, and unique, because we don't want anything worse than having stuff we don't need in a word list is having repeated stuff we don't need in a word list. Right. Okay, the next example is using a website and trying to get some words off that website that we can use. In this case, it's a Chinese site, a TV website. So what we do in this case is we've got the site. Just scrolling through it, you can see what is in it. It's just your average page, different kinds of advertising and news on it. So we take the URL. We're going to use wget to get the URL. I'm sure you're all familiar with how to use wget. If you want to have it go deeper on the web page, you can do that too, and then just cat all your output files into a single one. So here we have this output, Chinese page.html. I'll show you what it contains. Right, so there we have Chinese characters. It's all nice for a word list, but we've also got all the other junk that we don't want in a word list. And all of that junk surrounds characters that we actually would like to have, these Chinese characters, in our word list. So let's get rid of that. So we're going to call the tool. We're going to pass it that Chinese file, and we're going to use the dwebify command. Right, so what it's done is it's given us just words back minus some of the markup. But there's two issues here. One is we're still getting some text from the markup, from HTML. We're also getting quite a bit of English. Right? And our target here was to get Chinese words out of this list. We didn't just want English words out of it. It doesn't really help us to get those. So what we're going to do is run the same command again, this time with the no UTF-8. Right, so now we have a lot more just the characters that we're looking for in this file. You will notice there are still some characters floating about that we don't want. You'll see some scrolling down now. There was a number 2. The reason for that is I only check the first character when doing the no UTF-8. I'm still testing if it's worth checking them all. If it is, I will update the tool accordingly. But for now, if we output that, we then have a file that we can use with Chinese word list in it. You can run that through whatever other tools you want to actually process it and get output that you can use from it. Hmm?
Surely the remaining stuff is UTF-8.
Yeah. Okay, then the next tool that you need to use quite extensively is RLI. It comes with Hashcat. It's part of the Hashcat suite of tools. And what that does is it basically takes 2 word lists and gives you the unique passwords between them. Because the next problem you're going to have is multiple word lists, and what in this list of word lists is actually my unique passwords I can get out of it. It's a very fast tool. It's written in C, so it outputs nice and quickly. It's clean to use and very handy to get the differences that you can output for your unique passwords. And then splitlen, which is short for split length, is also a Hashcat tool, and a very important tool, and something that you'll find boosts your cracking capability a lot when you do it. Always split your word lists into separate word files split by character. So 1 character word list, 2 characters, and so forth. Now, initially that may seem unintuitive because you're going to have a directory full of files with different character lengths in them. But you can do a lot with that. For example, you can take your 4 character file, run that on your hashcracker combined with your 3 character file. Right, join the 2 words together. You can take your 8 character and your 2 character. You can take your 8 character and your 9 character and join them in different combinations. Or most of the tools, John and Hashcat included, just give it a directory and you can run it as though it was your whole word list file anyway, because they will run everything, all the subfiles in the directory. So you're not losing the ability to use rules, to use one word list as it were, but you're splitting them up into manageable sized files based on the character length that you can use, and you can do quite a bit with that as well. So let's have a look at a case example. In this example, I downloaded a 15 gig example word list. It's been on the net for long. It's called crackstation.txt. Right? It's 15 gigs once uncompressed. I then optimized it using just the ruler sort tool, and I uniqued it, and I got it down to 1.1 gigs. Right, so the two things we then did in step 3 is obtain 20 random passwords from a leak, which I won't name, but it has something to do with web hosting. Then the second test was the old LinkedIn dumped hashes from 2012. I got all of those, and I ran those too. So the goal here is to try the 15 gig word list, the one we're referring to as our inefficient word list. That list plus rules, then brute force, just to see how brute force compares into the picture, and then our optimized word list plus the same rule we used initially to see what we can get out of that. And then I'm just listing the hardware that was used for this test. Right, before we carry on, just a reminder to order your tools correctly. Right, so don't run maximum length strips before your Wordify and your no sentence. Don't run minimum length before trimming the characters. Remember to unique. Right. As I said, there's nothing worse than duplicates in a word list file to make it ineffective. Run your no numbers towards the end because you may have trimmed words down to only numbers. And then split your word list up accordingly. In this case, I haven't for this test because I'm only attacking one particular type of scenario. But in everyday life, keep your word list split by character sorted. Right, so the scenario 1 is crack as many out of 20 passwords with our plain word lists. As I mentioned, the plain word list plus rule, brute force, optimized word lists. Second option was crack the higher percentage of passwords with plain word list, optimized word list plus rule, and so forth. So let's have a look at the results. Right, so first we have the plain word list. Okay, just the one we downloaded, the 15 gig one. Right. So we cracked 5 out of 20, which is not a very good number to crack, password-wise, right? The other problem with this is our runtime, okay, 7 minutes, that's not too bad. That was across 5 GPUs, but that didn't matter whether I had 5 or not, because our GPU utilization was very bad at only 33%. Right. We weren't using rules, we weren't mangling or anything like that, so we didn't really give them much work to do other than comparing and generating hashes. Then we took our plain word list, the 15 gig one, and we combined that with rules. Right? The picture improves a bit. We've given our GPU something nice to do now. They were maxed at 100%. We cracked 14 out of 20 passwords. That's a good number. But we increased our time. Our runtime now was 65 minutes for this test. Not bad, but also quite a time to wait for 20 passwords to be recovered and to run through a 15 gig word list. Right, then we brute forced just to check. We went up to 8 characters, all characters, so that's everything, special characters including upper, lowercase, etc. So in Hashcat, that is $A is the placeholder for those characters, up to 8 characters. Very bad. We only cracked 5. We did keep the GPUs busy. We also, although we're starting to set them on fire at 2-hour runtimes. Right, so brute force wasn't giving us very good. We actually capped it at 2 hours of runtime. It was, I think it estimated about 1.5 days or so for the full attack. If you're not getting anything and you're desperate, yes, let the thing run on brute force. But in this case, it's not very efficient for us. Now look at the optimized word list, the 1.1 gig word list, what that gave us. We cracked 11, only 3 less than we did with the full list, right? With the rules. 100% we used to utilize our CPU well, and it only took us 6 minutes to run that. So we definitely got more out of that, because taking the 120 minutes on brute force, you imagine how much more we could have run, how many more rule combinations, how much more we could do with our 1.1 gig optimized word list. So there's everything laid out on for the screen for you to see. So least effective was the word list only. Okay, it should probably go to brute force, but the brute force did keep our GPUs busy, so the least effective was the word list only. And then most effective in line with keeping GPUs busy, lowest time and most password we could get in that scenario was using an optimized word list plus rules. The second scenario was the LinkedIn one. Right? In this scenario, word list only, cracked 24%, took 8 minutes to do that, utilized 61.4% of our GPUs, and that was in the 15 gig file size. Now look at the optimized one. GPUs get much busier doing something now with the rules. We use best64 in this case. Only 1.1 gig file was required, and we still cracked 19%. So only 5% less than using a 15 gig word list. By throwing more rules at this, we would have probably gone way past that and done even better than we would have before. And there's the results for scenario 2, comparing the two. The slides will be up if you want to get them later on. So that's the end of my talk. Basically, in conclusion, so efficient word lists, you can't go wrong with them. The more you manage them, the more you rely on rules to keep your GPUs busy, get them to do the work on your CPU, the more passwords you will definitely crack and the better you will do at that. Thanks very much.